Hello everyone, welcome to another new episode of the Operate First Espresso series. My name is Oindrila Chatterjee and I'm a data scientist working at Red Hat with Michael, Isabel and Francesco. In this video, I'm going to talk about how you can create an AI pipeline on Open Data Hub using Elyra, Kubeflow and Tekton. In the previous videos, you saw how you can use Jupyter Hub and Git to work on various parts of your machine learning project and collaborate with your team. Your data science project may involve steps like data collection, feature engineering, and model training. Now, there might be several instances where you want to automate these different steps of the data science workflow and run your notebooks in an automated fashion in series or in parallel. For example, when we are trying to apply analysis on real-time data. Using Elyra with Kubeflow pipelines, both of which are available on Open Data Hub, we can directly use Jupyter notebooks and automate them in a pipeline without having to translate them into scripts. To achieve this, we want a simple workflow to make the life of a data scientist much easier. Using the Elyra Jupyter Lab image and the Notebook Pipelines visual editor, we can create and run our notebooks using Kubeflow Pipelines, which is a platform for building and deploying scalable machine learning workflows. An instance of Kubeflow Pipelines is available for our use in Operate First. You can find the endpoint in the operate-first.cloud website by going under Users and Kubeflow. To access Elyra from Jupyter Lab, you can launch the Elyra notebook image from the Jupyter Hub spawner page and select a medium-sized container image. I already have the repository cloned into my Jupyter Hub environment. I'm interested in creating an AI pipeline out of the notebooks my team and I have developed in the past. Using pipelines provided by the AI COE tooling, we can leverage bots that help create container images for our projects. In the previous video, Francesco showed us how to create content images for your projects using AI COE tooling. Using the thought bots in the AI COE pipeline, we have already created separate images optimized for the different steps of our ML workflow. We have a future video talking more into the details about the pipelines, so stay tuned for that. These images, which contain dependencies optimized for each step of the pipeline, are available on the project's query registry. So as you can see here, this is an image for the download data step, and this is an image for the training step of our workflow. We will now add these images to the Elyra metadata. So for that, you can open the command line by using Ctrl+Shift+C and select Manage Runtime Images. Once the new panel has been opened on the left-hand UI, you can click the Add button to create a new image. Here, I will fill in all the required fields to create an image for the download data step. I will add a name for this runtime image and a URL of the image on Quay, then hit save and close. The image for the download data step is now available and can be used into our AI pipeline. I will repeat the same steps for the training step of the ML pipeline. Once this is done, we have a runtime image available for the training step as well. Next, we will create a runtime to be used in the Kubeflow pipeline. For that, we will again open up the command palette. We will click the plus button to add a new Kubeflow pipelines runtime. There's also an option for Apache Workflow, which is another workflow management platform, but we will select a new Kubeflow pipeline runtime here as we are using Kubeflow workflows. We will also insert inputs for the runtime here. I'll provide a name to the runtime that we are creating. We can also use the Kubeflow API endpoint, which is available to us through Operate First. The engine type can either be Tekton or Argo. Our deployment uses the Tekton workflow engine, so we will select the Kubeflow Pipeline engine as Tekton. Provide the cloud object storage credentials like the endpoint and the username, which is the access key, the password, which is the secret key, and the bucket name. Once this is done, we will hit save and close to create the runtime. Once we have created the runtime, open a new Elyra pipeline editor and drag and drop the notebooks which we want to add to the pipeline. To launch a new pipeline editor, you can go to the launcher by hitting the big plus on the left-hand panel and click on Pipeline Editor under Elyra. To add notebooks to the pipeline, we can drag and drop the notebooks we wish to include and connect them using this intuitive UI. Here we want to add the download dataset and the model training notebook in sequence so that they can be automated. So for that, I'll drag these notebooks and connect them. Next, we want to insert inputs for each step or notebook in terms of the image runtime, the environment variables, and the necessary resources by going into properties. So for each notebook, we will select the runtime image that we created specific to that notebook. We will specify the CPU and memory requirements for each notebook or step in the pipeline. Any dependencies on other Python files and notebooks can also be specified here. However, please note that these files must be present within the same directory. We will also specify the environment variables used in the notebook like debug level, the dataset location, the project name, the tutorial USEF, and the cloud object storage credentials like the endpoint, the username, the password, and the bucket name. We can also add comments and describe our steps here. I will repeat the same steps for the training notebook. Next, we will save our AI pipeline and trigger it by hitting the run on the top left. At this step, we will select the runtime platform as Kubeflow Pipeline's runtime and the configuration that we created above. Now, to view the running pipeline, we can switch over to the Kubeflow UI, which takes us to the experiment. So by clicking on Run Details, we can see that for each step of the pipeline within an experiment, we will have a box like this. To view the running logs and debug the pipeline, we can click on the steps and go to logs. This makes it very easy to debug any step that went wrong during the execution of a notebook. Now, once the steps have run successfully, we should see a green check mark next to each step of the pipeline. Now, in order to confirm and make sure that they ran successfully, we can check whether the model was stored successfully in the bucket using the command line interface or by using Boto3 in Python. And there you go. We can see that the stored model is present in the S3 bucket, and we can validate that the triggered pipeline ran successfully. So this is how we automated our notebook workflow and created an AI pipeline using Elyra and Kubeflow pipelines. What do you think happens if I modify a step of the pipeline and add a new dependency? We will be covering this in an upcoming episode. So thank you for watching, and do join us again for the next episodes of the Operate First Espresso series to learn more about cloud native data science development.